Okay, so because the cart is heavy and difficult to transport, it won't be in the senior design lab, but we will give just a brief overview of kind of the systems and functions that are incorporated. So we'll start, electrically at least, we'll start with the battery. So we've got a breaker and a contactor. Everything passes through these sleeved wiring harnesses, and everything is connectorized so that we can remove the harness completely and remove components as we need to. The harness isn't completely finished. We've got the fuel pump here. The fuel pump is just an automotive fuel pump that we're controlling via PWM from some motor drivers on the digital engine controller. At the digital engine controller, we've got this relay block, which is driven by this low side relay driver chip. We've got a fuse block. Two of these fuses are for power to the FADEC, and then the rest of the fuses are for various relay switch functions. Inside the FADEC, we've got a microcontroller to read tachometer. We've got two thermocouple amplifiers, one of which is being used right now for this exhaust gas temperature thermocouple, the other of which will be used for the power turbine, which will go right here. So the two thermocouple amplifiers, we have this oil system controller. We're running electronic oil pressure regulation. So to maintain oil pressure, we are controlling the speed of the oil pump via PWM with one of these. These speed control ICs are kind of fancy. They've got active freewheeling to keep things nice and quiet. One is for the oil pump, the other is for the fuel pump. And the oil pump IC takes feedback from this oil pressure transducer and runs a simple control loop to regulate the oil pressure. The oil pump and pressure is required, so the oil goes through the radiator, down into the oil filter, and then out to the turbocharger housing, where it goes through the journal bearings and returns. And we require very carefully controlled oil pressure because the journal bearings, there's actually no ball bearings in there. It's floating on oil. And in here we have the main microcontroller, which is responsible for sequencing startup, running, and shutdown of the engine, as controlled by some controls on the steering wheel, which aren't quite here yet. Also, we've implemented an emergency stop, which cuts power to everything that can produce flame or ignition. That includes the ignition coil, starting fuel solenoid, and the fuel pump. And then we have just a key that turns this contactor that turns the entire system on. We've also got an XB integrated for optional output of telemetry, and even the potential for remotely controlling and testing some of the systems on the cart. So back here we have the oil reservoir. We've got the oil pump. This is a driver on coil near plug ignition system. It's from an LS2 engine that we use for kind of a one-time ignition. We have gaseous starting fuel, which is a feed of butane into the combustion chamber to get things hot enough to burn diesel, which will be the primary fuel. Around the back here we have the starter engagement solenoid, which engages the starter shaft with a receiver on the rotating component of the engine. We have a 2 kilowatt starter motor in here, the starter motor ESC, so the electronic speed controller for the starter motor. Here we have an Omron open collector optical sensing unit that will run fibers in again to the rotating assembly to sense light and dark spots and detect when it transitions from light to dark and how many times it's rotated. That runs into the tachometer in the FADEC. So basically, these are all the systems that we're attempting to control and get working for this engine to run.